All right, I am back. Sorry about that. So I got a brand new Mac. Forgot to reinstall all my stuff. Haven't been on YouTube in a while. I'm up to 400 subscribers. I don't know how that happened, but thank you to everybody who subscribed. I'm gonna be now that storm season is up and rolling, doing all kinds of stuff, filming, doing the time lapse film from the windshield, as we're hopefully chasing really cool looking stuff like the tornado that I caught a couple of weeks ago. If you haven't seen that, go check out my reels and go look at my IGTV, and I've got that posted. It's pretty cool. So there's a major tornado set up today. There's already three reported storm spotter verified tornadoes that's on the radar right now in Alabama. Now, why am I sitting in this chair right now instead of out there chasing? Well, many reasons, but these are the types of things that I don't chase these kinds of setups, and there's a couple of reasons why. So, being from East Texas and seeing all the trees around here, I just don't like it. I don't. I'm there now for the photography, and so usually this is just a gray mess, and you can't really see what's going on. Uh, More power to those people, some brave souls out there that see the trees shaking and maybe an F4 tornado coming across the street. So we'll leave that up to them. But if you are interested in that kind of thing, here's some of the stuff that I look at on a routine basis, if not daily, that I go through to justify whether or not I sit here and film a YouTube video or I'm actually out doing the chase. So I'm going to share my screen and we're going to take a look at Radarscope. We're going to take a look at the College DuPage weather models, and we're also going to look at what the Storm Prediction Center has to say. And there's actually a couple of other opportunities tomorrow, Saturday, for maybe getting some cool stuff. We'll see. We'll see what the upgrades look like. So here is Radarscope. Here's what's going on right now. And so you can see there is a tornado, tornado. Right now, there's a tornado warning right south of Birmingham. And the storm setup just keeps, it looks like it's regenerating over and over again. And now it looks over to the west. There's another setup coming and it's going to sweep through. And then per the HER models earlier today, I was looking at it and it looked like maybe early afternoon through to late evening was going to be the greatest threat for tornado from Tupelo down to Tuscaloosa. And so right now I think this moved into where I think that threat initially had been stated on the models. And so there's a couple of things you can look at. You can look at this as the super res reflectivity. It gives you the storm tracks. It tells you any of the ping reports. I don't have spotter locations turned on because it just kind of looks like a mess. But that spotter location can kind of give you a good cheat. And you can say, all right, what's this person doing? So there's a few out there that I trust, that I know, hey, if this person's set up, they're going to get something. Bob Pack here in Texas, if you're watching, that dude is always exactly where you want to be. So, if you see him going and the storm's going this way, but Bob's going that way, you might want to consider what Bob is doing because he's usually right. And there's a couple of other folks. I also look at the live chasing, but these storm tracks have been shifting from mesocyclone to normal cell to downgraded. And this is one of the first times I've personally seen where they've got a tornado warned area that doesn't necessarily have the cell indication. So there's not the circle with the information or mesocyclone. So I think what they're predicting is that regardless of what the storm is doing right now, based on the history of this storm, it cycles up and cycles down. And so right now, if I was in Lake Purdy, Alabama, I would probably be heading for shelter or getting the heck out, headed south, get away from this track because it could it could have some serious damaging winds. And the Storm Protection Center was saying hurricane force winds, so that's pretty insane. So what led to these conclusions? How did we know that this was going to happen today? Well, if you've never seen it before, go to the Storm Prediction Center. This is the NOAA's National Weather Service Storm Prediction Center, where they do what's called weather outlooks. And so there's convective outlooks, there's mesoscale discussion, means large scale weather patterns that have some sort of typically rotating storms involved with it. And then they give these outlooks that go through day 1, 2, 3, 4, 3, 8, and then they tell you what the probabilities are for severe weather. So here's today. Let's pull up today and let's take a look at this. And it's just a big, giant pink bullseye. And so pink is high. That means that's about as good as it's going to get. If your goal is to go see tornadoes when you see pink, there's a very strong likelihood. And they even take it a step further. So they'll give you a tornado probability. And I mean, the tornado probability, it's a loose figure. It's probably extremely conservative, considering that we've already had 3 tornadoes today. But there's a crosshatch area here in the pink that says 30% chance of seeing a tornado. That's extreme. That's high. I mean, you can see tornadoes when it was 5% chance. And so just any chance where you've got a tornado chance that is indicated here and it's lining up with this high, you know we're probably about to see something. And so what I like to read, and it's just fun reading, is going through the actual discussions and looking at what the Weather Center has stated about these storms. And it's a great learning tool for me as we're going through, looking through all the data. It can kind of get muddy quickly trying to figure out, well, what should I focus in on? This helps condense all that data down into a really concise narrative that says, here is what's happening today, and here's what you should consider. And so let's take a look at the synopsis. When the very first sentence is several long-tracked supercells, you know it's going to be a good storm chase day. The most persistent and intense supercells will be capable of producing strong to violent tornadoes. That's where the red alert kind of goes up as a chaser, that you're going to be looking at some significant wind. You're going to be looking at, and right here it says like large hail, if not baseball size hail, and substantial damaging winds, meaning probably 70 miles per hour plus, and it could be sustained in some areas. An outbreak of tornadic supercells is expected this afternoon into the evening. Well, we're not even into the afternoon yet, and we've already had an outbreak of tornadoes. So we're not done yet, and it's going to happen some more. I think it's going to start a little bit south, from Birmingham down to Tuscaloosa. There's going to be a line there headed from east to west that somewhere in there's going to be some sort of cell. We'll go verify that here in a minute using the HER model. Talks about the low and how it's going to eject northeastward. So this is where it gets into like really tech, meteorological data language. And if you just take a look at the simplicity of it, you've got a low and it's sucking up all the Gulf moisture. So everything from the Gulf of Mexico is getting lobbed up into Mississippi and Alabama right now, creating these insane dew points. So 70 degrees Fahrenheit dew point is muggy. So I live in Houston. That's the norm here. But there, where you're interacting with cold front boundaries, that kind of thing, and you get the 70-degree dew point, that is intense moisture that's going to interact with all these other ingredients that is very likely to create tornadic situations, as indicated here. And then you have the potential energy in the sky. The 2,000 joules per kilogram is pretty extreme. It's not like a summer storm, but for right now, where we've got the 70-degree dew point, 2,000 joules per kilogram is just right. That's just right. That's enough to create mass chaos in the sky. And so that's your instability. That's where all that energy is going to create this massive updraft rotation. And then what I like looking at is the strong low-level shear and looking at those numbers. And there's a massive, massive low-level shear here. I mean, there's enough fuel, enough suction, enough wind, with the dew point, with the energy all together. This is primed environment for a tornado. And so once you go through this discussion and you really try to figure out a target area based on this, so here they kind of make it easy for you. You could look at it from Birmingham, Tuscaloosa, Hoover, Alabama, anywhere in there, as long as you're within like 50 to 100 mile radius, you're probably going to be in good shape to catch something. But you can actually narrow it down even more. And so the next step is go to the HER model. And I actually don't look at the HER model first, but we'll go ahead and look at HER right now so we can kind of see where we're at. I look at the 12Z because it gives you a much longer window, and you want to pick your geographic region for analyzing. And so we can take a look at the southeast region, click the simulated reflectivity, and this tells you what the cells are going to look like, where the tracks are, where supercells are likely to exist, and you'll see that with these little black lines here. And you want to look for like the really, really dark red, and you want to look for stuff that just persists. So yesterday we all screwed up. Well, there were some chasers that were on it. There was a tornado that hit yesterday in Texas, I saw it, I knew it, I didn't leave the house, but there it was. And there was lonely little supercells, as Pecos Hank would say, just drifting across Texas. It's just no other precipitation, totally dry, perfect little supercells, ideal. And we could see that on this HER model. In this scenario, this looks like high precipitation type environment where it's just going to be gray mess, and tons of rain, just misery from all angles. But with the simulated reflectivity, we're going to be looking at the Zulu time, and I'm going to go back to select the model that's already run the 12Z, and we're going to compare. And so what I like doing is comparing from model to model to model to see if anything is substantially changing, see if the model is aligning and agreeing with itself over time, and if it is, it's a good likelihood that that is a real cell that's going to develop. And so let's take a look at this. So you can fast forward and you can see where we go way out into Saturday. So let's take a look at where we find where the cells end. That's where it ends right here, and that's about 6Z. So I'd say about midnight tonight, we're going to see an end to, well, there's still a track in Georgia. So I'd say even Georgia into midnight, and you can see that area right here. There's a couple of tracks here likely to create tornado situation in Georgia at midnight. But let's keep going back in time. Let's go back in time. So around 10 p.m. or so, right around the Georgia border, you're going to have some long track supercells. And then back in time some more. We'll go back about 8 p.m. We're going to be right over Birmingham. Continue, and let's get to where we're at right now. So what time is it out there? Say it's about 3. We're going to get to 3 p.m. here in a minute. And so with Zulu time, I'm just subtracting 5 hours. And so right now at 19Z, that would be right now. And so you could see that there are a whole bunch of little sputtering of cells here that look to be somewhat isolated before it develops into a nasty multicellular high wind, bow echo, squall line, cold front, whatever you want to call it. Those are nightmares to chase. What you want is these little discrete cells that you can go and park right next to and watch it fly on by. So right now, I think this is matching up fairly nicely. So let's go back to the radar and let's see. Let's see what it looks like. And it's almost the same. So you can see from Mississippi to Alabama, there's a few little discrete cells here. I mean, there's condensation, there's precipitation in between them, but it's not a massive squall line yet. So there's still a lot of little tiny embedded cells here, like this little guy right here. There's this tornado vortex signature right here. This one looks like the classic supercell, probably the dominant cell out of all of these right now. This is the one that keeps cycling and turning into tornadoes. So let's take a look at Birmingham, Meadowbrook. It's 2 p.m. Let's go back to the HER and let's see what it says. So 2 p.m. Let's go over Birmingham, and there it is. So here's your long track. There's the supercell right there. And let's go back to the radar, and it's almost identical, if not 1 for 1 identical for the exact size, shape, location, everything. And so the HER can be extremely reliable. In some cases, it can be very unreliable, but it does a really good job of letting you know, here, this is where I would be. So if I was doing this chase, I probably, knowing this, I mean, this was predicted, let's see, 12Z, I mean, this was predicted yesterday. So I would have been not in Mississippi, I would have been in Alabama, and I probably would have been a little bit south, probably southeast of Birmingham somewhere, but it all depends on the roads too. So you have to plan that if I'm going to hit that cell, do I want to be there with it over top of me, or do I want to be coming up to it as it's forming? And so you have to make your own decisions there. But you do have a really good track here. So Harpersville is probably where I would have been sitting. And then I would probably take, it's just a bad road scenario, I'd probably be here on this Harper Road to Pell City, because this is a nice road that kind of follows the storm path. You still kind of have some risk here of this kind of going over the road and you getting in the path of a potential gigantic tornado. But the roads here seem to be pretty decent to follow this track. So I'd be tracking from Harpersville probably to Pell City, and I'd want to stand up in front of it so I can get a picture of it. Whereas some of those guys get up in here in the notch and they're looking right at the rotating wall cloud, which is what I did a couple of weeks ago. got a little wet and got in the path of some rain bands and some circulation on a tornado. So this is just as simple as it gets. I mean, you look at the HRRR and you go back over to the radar, but there are some subtle nuances that if you do want to take the game a little further. Okay, good. The 17Z model just updated. So this is the latest model, and that's right now. And we're looking, it's almost identical to the 12Z. Maybe a little less activity, maybe. Let's bump this up to the same time frame. So it's 18Z, and then so it over predicted just a bit on the 12Z, but what's weird is the 12Z actually looks more representative of what's going on right now. And if you look at it right now, it's showing that cell is about to die off. Maybe. Let's see what happens. Yeah, so it's the one that we're looking at right now with the tornado vortex signature. This one right here, the newest, latest, greatest HRRR model is saying that that's probably going to dissipate, die off as it hits the Georgia border. But we got some new stuff coming up, and this right here down in Mississippi, this is where, from what I was reading yesterday, this is where I thought like the big tornado was going to happen, would be somewhere down here from Jackson. Let's see, is that Jackson? Let's see if I know my geography. If you go back over here to Mississippi, I'm guessing that it's probably this dude right here, this one right here, right next to Tuscaloosa. I know a lot of those other storm chasers were up. I saw a big, just critical mass at Tupelo. I think that was too far north based on what the tracks look like. I think that down here, Tuscaloosa, even over here in Marion, just any of these areas to the south, we're going to be better off trying to get up, because you don't want to get behind this thing because you're never going to get in front of it again. And it looks to be matching. So they've already tornado warned what the HRRR is saying right here. And let's see if the HRRR is right. It's almost 1-for-1 again. So the model is matching up to what is reality, meaning that you can literally trust the model from this point forward, in my opinion. But now that you're out and about, I don't really look at the model anymore. I'm just looking at the radar and actually visually seeing where is this storm going and what's actually happening and where are all the other storm chasers going. So the prediction is good. The HRRR model was good. The Storm Prediction Center looks to have nailed it. But what are some other things that we could have done? So I like to take a look at the soundings. I like, just maybe it's because it's interesting to me, but it helps me learn based on where the actual convection is taking place, where some of these tornado parameters line up, the significant tornado parameter, the supercell composite, and I start looking at where would this be. And so I'm looking now, and it seems to be lining up pretty nicely with the actual HRRR model. And so I'm trying to line this up. So this will be about 3 p.m. and the HRRR model is saying right east of Jackson, Mississippi, and that's exactly where it is. I mean, so this STP yesterday was off the charts. So it was 10 plus. So the threat has lowered to some degree, but that doesn't mean anything. It's still super prime target. And so let's take a look. Let's click. So here's what I like doing. I like taking a look at this STP, lining it up with some of the worst spots, and then going and taking a look at the simulated sounding. And it's talking about significant tornado outbreak. That's what the sounding says right here. It says 90% chance of, or on a 0 to 11 scale, a 9 for EF4 greater tornado. And I start looking at some of these CAPE numbers, mixed layer CAPE. That's about right. So they said 2000 on the Storm Prediction Center. This is 1770, so we're close. But I also start looking at this effective shear number, and you can see it on the hodograph, or you just read the number. So I like looking at the number, and it's like 86 knots of shear. It's insane. And let's see if we can do the math. Calculator. I should be able to do this in my head by now. So 1.15 times 86, that's 98 miles per hour of wind, 100 mile an hour of shear. It's insane. The other thing I look at, and I've heard this, read this, I'm not sure exactly the physics behind it, but when you look at the storm slinky and you look at critical angles, you're looking for about 75 degrees. And like clockwork, I've been studying it this year. Every time it's between like 60 to 80 and you really are in that 70 something degree range, a tornado has happened. So the tornado that I chased a couple of weeks ago, the tornado yesterday, so the tornadoes from the other southeast outbreak all had a very similar storm slinky. So there's a pattern there you can recognize. Looking at the supercell composite, this is off the charts, 28.8. STP, significant tornado parameter. This is fun to say. It's off the charts. But what's different here from what I was seeing yesterday, looking at the soundings, is it's less cape overall, meaning that the storm, it was over predicting the strength yesterday. And the overall LCL, everything, wow, but the actual inflow layer at the 3 kilometers that's insane. That's tons of air. So I didn't look at this earlier, and that's a lot of air. So the bottom shear, 41 knots, 50 miles an hour. 3 kilometer shear, 72 knots, about 80 miles an hour. The effective inflow layer, that's where all that energy comes in for that tornado, is just a big monster truck of air at 66 knots moving in. So you wouldn't expect not to see a tornado today. But what's interesting is there's not any supercell or severe hail quality matches, meaning that they go back in time and they'll go through all the real soundings and they'll say, this setup looks very similar to all of these other setups, and it matches. So the likelihood that you're going to get severe hail, tornadoes, and there's 0 here. So I'm kind of surprised by that. But what I do with this sounding, if I find one that I like, and I'm not necessarily liking this one because it's, I don't know, the ones I was seeing yesterday were a lot more powerful. But what you can do is you take this latitude, longitude, copy it, and just simply paste it into Google. And this tells me where I need to be. And I don't necessarily go to this GPS location, but I will create a triangle. And I was doing some reading on the significant tornado parameter, and you might not necessarily want to be in the parameter. You might want to be on the gradient of the parameter. So meaning, don't be posted up at the strongest point. Find a gradient and stay there, because that's where all those variables are mixing. You've got the dew points mixing with the drier air. You've got the shears. You've got all the wind mixing. You got the cold front. You got the boundaries. And so you want to see where those boundaries are at and find yourself a gradient, and that will give you a great likelihood of seeing a tornado, in my opinion. And so this would put me at Columbus, Mississippi, right on the border. And so, okay, so based on this analysis, I think I was correct yesterday with saying I think Tupelo is a little bit to the north for where we would want to be. And so I'd probably would have stayed the night in Starkville, Mississippi, and woken up today and just stayed put. I probably wouldn't even have chased the stuff over into Alabama. I would be waiting for what I consider to be the real show. Hopefully that doesn't anybody in any path, there's no Birmingham path, because the tornado track right now looks to be going a little bit to the north of Tuscaloosa. So it's going to split the difference between Tupelo and Tuscaloosa. So if we take a look at that sounding and that GPS, so it's right here, so West Point, let's go map that up to the radar right now, and let's see how accurate that sounding is in predicting some of the severe weather. So let's find that road from Tuscaloosa. Let's go find my town. Let's go find my town here. Let's see, what town was that called again? Where are we at? Let's go zoom in. So let's find some, there's Carrollton, there's Pickensville, there's Columbus. So Carrollton, Pickensville, and Columbus. Let's go see if we can find that on the radar and see if my pin here matches up and if I would have been correct where I would want to be. And again, I'm not cheating because this pin right here, this is based on the data from right now. So this model's saying now this is where you should be. So you would expect it to be fine. But some of the pins from yesterday where I was reviewing the data had me somewhere around this area, and I wish I would have screenshotted that stuff. So here we go. Pickensville, Carrollton. It's exactly where it's saying it should be. I mean, it can't be any closer, actually. I mean, it's insane how close that is. So the soundings help me determine a GPS location, because you can take a city and you can say I'm going to be in Columbus or I'm going to be in Birmingham. that's a huge area to potentially miss your target. And so I'll come up with some soundings. Let's go see if we can find some other soundings based on these parameters. So then I double check. So let's go take a look at the supercell composite. Let's go pull the time up for right now. Let's see, that's it right there. And let's go put, so again, that same area, super pink, very high 20s, maybe close to 30 on the supercell composite. And it'll tell you, actually, if you hover over with your mouse, it'll tell you where you're at. So the supercell composite's about 22 right here. Let's go click this. Let's look at the sounding. And now we've got PDS tornado. We've got very similar figures. We've got similar inflow. We've got all the same stuff from the random one that I picked based off the STP. So here's the random one I picked based off the supercell composite. So let's go copy this GPS over and let's take a look where that one lies. And I would expect it to be somewhere close, but sometimes it's not. Sometimes it's maybe 20, 30 miles away. So this is actually Pickensville, exactly in Pickensville, between Pickensville and Carrollton. So this is, to me, I mean, you cannot get any better than this if you're trying to pick a spot where to be. Because look at here. So Pickensville, Carrollton on Highway 86, right here. Let's go look at the radar. Pickensville to Carrollton, Highway 86. Here's the mesocyclone right here. See? So I'll zoom in even further. So that pin, let's match this up one for one. That pin is sitting right here. So that GPS pin that I just dropped would have me sitting on this road between Pickensville and Carrollton. Now, to be honest with you, it's a little bit to the north. But I mean, I don't know how any closer you could get, and I'd probably want to be east of Carrollton and then find a road as quickly as possible, which it doesn't appear to be without having a better map, to go north with this storm. So I think the only option here is you'd have to stay on this road heading towards Coker from Carrollton, and then maybe there's a road going to the north, hopefully northeast, and that would be a perfect scenario. But if I followed that logic and I followed that rule using the NAM model and using the soundings, it would have put me exactly where I needed to be, especially if my general target was right, meaning I was already in the geographic region to begin with based on some of the earlier analysis. So let's go back to our other data on the NAM model. So let's go look at some of the other products. Let's look at the actual wind speed. And what you want to see is, maybe 30, 40, 50 knots. If you're up here in the red, which this is 79 knots, 80 knots, just incredible winds, like 85 miles per hour in the 500 millibar region of the air. And so if you take a look at this, it's going to move through, and there's going to be pockets of purple that are going to be actually up in Arkansas. And there's another little purple right here at the 21. Okay, let's go pick this. So this is independent. So I'm forgetting everything I thought about STP, which is significant tornado parameter. I'm forgetting everything I thought about the supercell composite, and now I'm just independently reviewing just wind and seeing one of the general areas within the target. And so here's a couple of purple spots, 103 knots. That's an incredible amount of wind. And so let's go click on that and let's see what the sounding looks like where it's 123 knots. Now they've just tornado warned the area that we were talking about before. Let's see if the wind lines up with all these other things. So here's our sounding. Again, hodograph, it's off the charts. Storm Slinky, 71 degrees. What's interesting about this is the tornado threat has kind of reduced to some degree. The STP is only 4.4, whereas before it was 8, so it's not really lining up, correlating one for one with the wind. But let's take a look and see where this high wind is. Let's go back over to Google. Let's drop our GPS pin and let's check where we're at. Probably in the middle of nowhere. And so Fayette, Kennedy, Winfield, Tuscaloosa. Okay, so this is tracking. So okay, this puts us right exactly on that same track. So that storm right now is sitting right here, and it's moving into this area of extreme wind. So let's go take a look right now where we're at. So that's Kennedy. Kennedy's here. You can see the storm track takes us straight through there. Kennedy is here. So that high wind area is sitting right here. There's Fayette, there's Kennedy. So the storm's tracking right into it. So if you wanted to, you could say, I'm going to stay with this storm and I'm going to see if that high wind does anything, has anything to do, because they just did another tornado warning here. And so we're going to be closely monitoring this to see if there's any kind of signatures. And let's see if we can pull up the actual velocity tilt. And doesn't really look tornado-y yet. What you want to look for is like really extreme bright green and then really extreme dark red sitting right next to each other. And that's opposing winds relative to the radar, which would indicate potentially a tornado. Not always, but if you see that on the radar, don't drive through it. And let's see if we can see anything else right now on the radar. This looks interesting right here. And there's a tornado vortex signature here. This very well could be a tornado on the ground. This over here. So this is the one I'd be watching right now, based on everything we just got through talking about, based on the HER model from yesterday, which said be here, based on the HER model from right now that says be here, based on the NAM model that says I agree with the HER model, but I also looked at the actual soundings of what the atmosphere looks like, took the GPS from where that sounding's at, and it maps up one for one exactly where that storm is at. And so this is starting to tighten up a little bit. So, but it also just lost its mesocyclone status, meaning this is probably going to cycle many times between non-cell, cell, mesocyclone, tornado, non-cell. And I've watched this do this today, and also watched it. It's almost like a repeat of the last storm system that came through the southeast. And so hopefully everybody's okay. Let's see if there's anything else we can talk about on the model. The craziest parameter, in my opinion, was the dew point line. I haven't seen really anything like it. Let's go back over to the southeast. Let's pick our latest model run that's complete, and let's go look at surface products, and let's look at dew point, and just look at this. I mean, for where I'm at, which is here, I'm in Texas right here. I mean, we're dry. It's like, this is really dry for us. It's 54 degree dew. I mean, it's perfect. It's perfect for humans, right? 55 degree dew point is perfect for human and environment. We set indoor temperatures and humidity at ideally 55 degrees Fahrenheit. Up here, we've got 71 degree dew point. I mean, that's like walking outside and just taking a grab of the air and holding it in your hand. You walk out with anything relatively cold, it's going to develop dew on it. So you have a Coke can that was super cold, it's just going to be covered in water here. And that's the whole idea, is that's the fuel, that's the moisture fuel for getting our tornadoes. But where I would be interested is where all these converging lines and the interaction between any kind of potential boundaries that this dew point's interacting with. So let's see if we can see this cold front, because that's what I think this ultimately is. It's a frontal system with a low pressure, and you can see there's a gradient here, but there's also a little pocket here. So this is the pocket where I'd be focused in on. So independent of everything else we just said, if we take a look at this, and you can't do the soundings on HER, so we got to go back to NAM. Let's go back to our surface products. Let's go look at the dew point on the NAM model, and let's see if it matches up. Let's go to where this is headed today, and let's look in this little area where there's a couple of pockets. So there's some massive, same as the HER, massive dew points. Let's just pick one of these soundings based on the dew point, nothing else. And let's see if it matches up with some of our earlier soundings. So it's predicting tornado. It's got massive amount of CAPE. It's got incredible amount of wind. It's less likely to have a tornado where I just selected. So you have to ask yourself, why? And so there's other parameters here at play. And so I think the target area we were looking at is right here. So let's go click one of these areas and let's see if it matches up. So this is confirmation bias right here, because I already know that that is the area. Yeah, so that pulls up a very extreme supercell composite score. It's got a very extreme STP score, off the charts on EF4 plus likelihood, off the charts everywhere. So you're in a good section of this storm if you're sitting right here, probably on this area between the 70 And so you can see the gradient going from 70 over to 58 in less than about 200 miles. So it's pretty tight gradient. So I'd be sitting somewhere in this gradient, and you would expect to see something. So let's check the radar. Let's go back to our radar. Let's see if they still have this tornado warned. And it's still early. It's only 2 p.m. It's only 2 p.m. It's still early. So I've had a tendency of looking at it and going, I think it's fizzling out, time to go home. And then 2 or 3 hours later, just like the HER model said. So that would be the analysis I would be doing right now. We've already got our target, and it looks to be pretty decent. It's not a mesocyclone, doesn't have tornado vortex signature, but it's on a known system that's already produced funnels and tornadoes. So the likelihood you're going to see one out of this one's very high, but I'm always planning ahead. Where do we go next? And so now I'd go back to the HER. Let's go find our HER model. Let's go pick our geographic region again. Let's go select the model run. And let's take a look at the actual precipitation products and look at where the simulated reflectivity is. See if there's any changes to what these cells are going to do. And it does look to have, I don't want to say fallen apart because it's still a strong system, but it's not what it was yesterday. And there's a definite threat here. So, I mean, if you're in any of these populated areas, any of these long track, these little lines here, that is where you don't want to be. You might want to be there as a storm chaser, but if you're in this path, get out, because you could definitely be in a path of a long tail, long track tornado. Here's one here as well, and here's one. So that one up in, like I was saying earlier, Georgia, so that border area, that would be an interesting place to be. But it looks like over time it is going to weaken. The system's going to weaken just a bit, and there's a couple of more discrete cells that are going to come right north of Birmingham. So this one would be an interesting one, and let's see when that is. So that's going to be, it's dark, you know, so it's not like we're going for photography. We're literally going to chase. So this is going to be a 10 11 p.m. chase, and that's dangerous. So if you're in Birmingham at 11 p.m., have the news on. You're in a direct path of a potentially dangerous situation. And I'm not a meteorologist. Stick to the pros, guys. And if you have any questions, go to Twitter, go to the National Weather Lab, go to the Next Generation Weather Lab, go to the models, look at it yourself, look at the radars, go to the Storm Prediction Center, read it, do your own research, and then watch the news. I was really impressed with the Lubbock news, watching Ron Roberts, watching the folks that have been doing this forever, telling me where to be while I'm sitting there telling me where to be, and comparing it to what the real meteorologists are saying, and they were dead on. They were absolutely dead on. So keep that in mind as if you're not a chaser and you're just watching because you know you're a fan or you really enjoy this stuff and you live in this area, please keep in mind that around 10 to 11 p.m., if you're in Birmingham, Alabama, this particular storm system can be very dangerous. All right, well, that was fun. This is some of the things that I look at for storm chasing. Oh, one more thing. So the other thing is, so today is one day, right? So what do we do the next days? What do we do next? And that is where I'm always planning ahead. So right here we got tomorrow's outlook, and we got day 3 outlook. And it looks to be repeat. So it's only a marginal threat. Doesn't mean anything. We had a tornado yesterday in Texas on a marginal threat. So it just means that the likelihood is less that you'll see a severe weather event. But let's look at where we're going to be. Memphis, Tennessee. It looks the same region. I mean, you got Tennessee now and Arkansas, the border between Mississippi, northern Mississippi, and Alabama. Any of those areas are very valid. But one thing that strikes my interest is this stuff up here in Topeka, Kansas. And then you would go down here and you read through and say, well, what's going on in Kansas? This is new. Is this storm season now? So are we actually going to start seeing stuff to the west where it's fun to chase, where there's no trees? And let's go look. Central Plains, weak surface low should develop over Kansas by Friday evening. Low amplitude shortwave trough, meaning a low in the region ejects northeastward across the Central Plains through the day. A warm front should extend east. So this is interesting. Warm front tornadoes. and it doesn't have a lot of cape, so there's not a lot of instability, but the dew points are there, the shear is there, and you've got a boundary. So maybe we continue. I mean, I'm not going to get in the car and drive up to Kansas, but I'm definitely going to use this as a study point. So let's take a look at this and continue keeping your eye on the central plains and seeing what materializes. And so that's tomorrow, and let's take a look on Saturday. Saturday seems to be another repeat. So, I mean, that moisture bomb, I think, just primed the air for significant storms. Now we have a little bit elevated risk, it's slight risk, and so I would focus again, probably around the same area. And you could probably just hang out in Birmingham after today and drive in a circle tomorrow and Saturday and catch storms to your heart's content. The lower Mississippi through Tennessee Valley region, so there's going to be thunderstorms early Saturday. So this is going to be morning, not fun. The activity will be embedded within strong vertical wind profiles, supporting potential for few organized structures, damaging wind gusts, and hail. So this just sounds like misery. I probably wouldn't chase it. I'd probably be sleeping. But if you did want to, this one will probably produce something. I don't know if it's a tornado, but you'll definitely get a supercell or two. But that would be the plans for the next 3 days if I was situated somewhere in Alabama. Oh, we got some activity over here. We got another tornado report south of Birmingham. I feel like a live news correspondent right now. And the way you can look at this on Radarscope is you click the report and it'll tell you where it came from. So this came from a train spotter, meaning they saw it. Numerous trees uprooted. Trees blocking highway. Why I don't like chasing East Texas all the way to the East Coast, because I don't like chasing in the trees. It's scary, and if you get stuck or blocked, the way this storm system's working, there may be a tornado in front of you, but there might be one right behind you. So keep that in mind. Let's see if we can see it on the radar. It's probably this right here. So that's a good little couplet where we've got some intense wind going this way and then intense wind going this way. It is definitely tornado warned since we've got a spotter report. Hail size has gone up, and we've got tornado vortex signature, and that's exactly where it said it was going to be. So I like the HER model. I like the NAM model. And a lot of folks have asked me a couple of days ago, like, hey man, how did you know where to be? How do you know where to go? Some cases I don't. I just kind of look at the radar and on a whim decide, hey, I'm going to go storm chase like I did the last Saturday. But if I'm looking for long term, I'm going to the GFS model, and I'm developing based on continental US. I just look at one thing. I look at the Cape. I look at where we're at for the mixed layer Cape and the shear. And I zoom in, and let's see if we see anything over the next few days. And there's an interesting pocket. There's a bubble here. There's a blip. Here in Nebraska, that's where we'd want to be. That's where the fun stuff happens. That's where it's pretty and you can chase and you can get the hell out of the way. There's no trees. Let's go look at the sounding. And so then I'll pick a sounding. And let's look at this. So this is April 6th. I mean, this is way on out. So this is, maybe 10% chance that this is going to materialize. But that's how you plan. And let's go look at the sounding. It's only a threat for severe right now. So it's got a pretty decent cape. Doesn't have enough, it's got enough shear, so it's got the ingredients. It's there, and so you just kind of watch, and it does have a couple of matching soundings from previous storm events. Is it worth getting in the car and driving and booking a hotel right now and planning ahead? Probably not. But as we start getting closer to April 6th, and as you start getting April 2nd, 3rd, 4th, on the 3rd and 4th is where you would want to make your decision. And if this still looked the same, if it still had the same parameters, and let's say it elevated a little bit, then you might want to get in the car. And then you might want to plan around a storm chase here. Let's go look and see if we have anything else coming up in the future. Nothing too interesting. Well, we've got another Nebraska event, April 9th. Let's go look at the sounding. And again, these are simulated soundings. Take it with a grain of salt because it's so far out, the likelihood, and then we got a tornado. So this becomes a little more interesting now because we do have supercell, tornado, slinkies right at that critical angle of 75, right on the money. The sounding looks decent, or the hodograph looks decent. So maybe this would be a target. And so you could say, looking from, and that's close enough in proximity to the 6th, where you could say 6th, 7th, 8th, 9th, maybe there's a chase opportunity somewhere in that window. So that's how I do it. Oh, wow. So let's go back over here, and it cycled again. It cycled again. So now it's demoted itself back to cell status. It was at tornado vortex signature, so it's doing exactly what we said it was going to do. It's going to cycle back and forth. I've seen some of these lose their cell status, gain the cell status, go to mesocyclone, go to tornado vortex signature. Spotter spots the tornado, it knocks it right back down after the tornado's gone, back to cell, and the cyclone process starts all over again. And we're now in a mesoscale discussion, which is very interesting to read, and that will tell you the immediate future of what is happening. This is something we haven't talked about right now. Mesoscale discussions. Let's go pull up current mesoscale discussions from the Storm Prediction Center. You can see right now we got tornado watch discussion. We've got a new one that was issued that's right here. So you can go through and you can, let's just go read this one. It's telling you basically aerial coverage of thunderstorms has increased over the past 2 hours. So it's giving you a near scope of window that says here's what we're seeing from a holistic perspective over the entire scale of this region. What do you expect to see? And it's talking about you're going to increase the low-level winds have veered in wake of warm advection to the northeast, which has temporarily reduced the storm threat. So that's what we were seeing in the soundings versus yesterday. So it is weakening to some degree based on what this mesoscale discussion is saying. A few cells may consolidate into supercells out of the larger area storms. And that's what we're kind of seeing. But as you can see, this one little cell here has 1, 2, 3, 4 tornadoes already. All right, folks, I'm going to hop off and go back to my studies. So I just wanted to hop on here, say hello. Thank you for all the subscribers. Thank you for all the kindness, the support. If you like this video, like it, subscribe, put a comment down. Come find me on Instagram, Adam Kyle Jackson. And if you have any questions about any of this stuff, I'm free. So put a comment down below if you have a question, or come find me on Instagram, put a comment on my posts. Easiest way to find me. Let's go back to the camera, get me off of the screen. And so I think moving forward, if it's something interesting, I may do one of these. Let me know if you like this. If you don't, if there's ways I can improve it. Is it helpful? Am I giving you tips? Am I telling you stuff you already know? I mean, I know there's tons of pros out there that know what they're doing, but there's also people that have never looked at this stuff before. And so I just want to kind of give you a overview of my process as these develop. And then eventually we're going to be doing it for real in the field and getting some cool video in the process. So you guys enjoy the rest of your afternoon. I am going to go see about virtually chasing some storms.